Okay. Yes. Someone asked about environment setting. Okay, this is very nice because in your project, in your project, you may need different kind of libraries, different kind of version. Okay, in different project you may need different kind of. That's why for each project you set the environment, and then after if you open that project, the environment automatically will open and it will not. Overlap with another one. Okay, this is the nice thing. We have some steps to set our environment. Okay, you can do, but in general, because now you are learning. Okay, you are in basic stage. That's why at this point of time, no need to set up your environment. Okay, you can only import. Hardly you will use NumPy, Pandas. Okay, scikit-learn, matplotlib, these things you can import. And after that, if you go for a big AI ML implementation like Torch, TensorFlow, okay, when you will use Tensor, then you need to first build environment and then after go for that. Okay, but initially, this point of time, start with a scratch. Okay, use the import the things. Okay, yes, for beginner. Okay, no need to worry about these environment. Okay, start to work, give output. This is the important. That this time, okay, we have 6 7 days, and then after we will meet. In these 6 7 days, you have to think. Most of you, some of you already think, okay, that what kind of real life problem they are going to solve related to cybersecurity. You may find from different field also. Okay, and try to solve this. Try to solve it in Colab. In Colab, you will not get some any kind of problem. But if you want to do on your system, some libraries may missing, some dependency may be there. Okay, that's why it's a free platform you can use. Okay, now these things that we are going to learn. Okay, try to do these things. Then in the next session when I will come, I may tell that how to set environment if I get time. Otherwise, you can get these instructions from online also. Okay. Okay. Now let's understand why we are doing descriptive analysis. Of course, I told you 80% of time is needed for understanding your data set. Okay. And in this technical documentation, I need from all of you that go from basic one by one. Okay. Look one future, one column, and then say what kind of data set is this? Okay. What kind of pattern it follows? These things we need. And this is the descriptive analysis. It means you need to describe your data set. Okay. No need to uh, predict or do something any extra thing. Only you need to describe. Okay, describe your data set. Okay, basic summaries about data set. However, it makes no attempts to interpret the data. No need to interpret. First, only you say that the data set that you have downloaded or you have captured from different tools that you are going to learn. Either you do by that tool, cybersecurity based tool, or you may perform these operations in using this Colab on Python also. Lots of libraries are there. Okay, you can import it and you can analyze your data, you can analyze your network traffic, and you can gather the information. Okay, and remember that we have discussed in basic Python. It is going to help you to clean data from gathering from different tools and then make into data frame. All concept we're going to use. Okay, that is small content we learn. Okay, but to perform this machine learning kind of thing, you need little bit same kind of data, same kind of implementation I am going to share at the end of this session so that you can perform your operations. Okay, but here you have to analyze, you have to describe your data set, and that you have to write on your technical document. Okay, suppose if you take some examples, suppose sample height, it's enrollment number, gender, height, and now you want to analyze. See, suppose the students in same year, then is it important to analyze this enrollment number column? No need. This common sense you must have, and this is the skill that you need to develop. Okay, and this thing you have to write in your technical document that if you find that some column is not necessary to explain or describe, then you write that this is not important, this will not impact. If actually it means you have to justify the things. Okay, and that's why I'm focusing with a little data set. I'm focusing that how we exclude our descriptive analysis and why we include and what kind of things we will do. Okay, now second, suppose a gender. Now gender, you can see you have to write this is the gender and what kind of data in this gender feature, gender column, and you can see here male and female, only two categories are there. It means this is categorical kind of data, and in categorical kind of data this is a binary categorical. Okay, these things you have to explain. And now the height is, you can see this is the number. Okay, this is the you may say this is the contiguous kind of thing. Okay, numerical values are there. Okay, but how you can represent, how you can describe? If you have categorical data, then you may go for a frequency table. Okay, that you can say that how many frequencies are there for what kind of category. Okay, you may draw pie chart. Okay, a bar chart. It means in any case you have to describe each column. Okay, see, I am indicating that each column in your data set you have to describe. Okay, separately. Do not think that you simply download the data set and then you perform some machine learning algorithms and then the model is there and that's it. No, you have to describe everything. Okay, uh, every column one by one, and how we can do this we are going to explain. Okay, but first understand that how we can plot, how we can describe. You have two methods, either you go for frequency table or you may go for chart. Different kind of charts are there. You may go for bar chart, or okay, you can check on internet. And of course since we uh, already done a lots of coding on Python, and I told you if you want to do anything, simply ask from your chat GPT or Google. Okay, you it will give you the code in Python, because this is very famous nowadays. Okay, every solutions are there. If you say that you want to draw a frequency table, okay, it will give you the code, or you want to draw a pie chart, you can find the code. Okay, that's why in this lecture I am not worried about the coding part. Okay, because you can draw. I am worrying about the conceptual part, whether you are able to understand or not. Okay, suppose mean, median, mode. I am not able to worry about how you can find mean. It's very easy. If you type that how you can find the mean of a column in Python, Panda, the solution will come, and you have to use that code. Okay, that's why focus that how you can what kind of concepts are there and what kind of concepts you need to explain in your technical document that you are editing. Okay, and second, you can see the numerical kind of data. Okay, this means a quantitative kind of data is there. Okay, for quantitative kind of data, you can use two things, either describing the central tendency of the data, okay, or you can use a spreadness of the data, that how data is spread from the central point. Okay, either way you can describe. Okay, but try to describe in both ways so that you can understand, you can learn, you can sharpen your skill. Okay, now if you talk about the central tendency, okay, because we are worrying about numerical kind of thing. The categorical kind of thing you can see it's easy, you have to find out. But numerical it's a little bit tricky. You have to think more. Okay. Now you suppose this is a one column. Okay, this is one column. You can see the row, but actually this is represent like this. Okay, it's a one column. Some data is there. Okay, this is one column like the previous one, like this. This is the one column. Okay, this data is representing like that. Okay, it may be 10, it may be 10 million, doesn't matter, but concept will be same. Understand? Concept will be same. That's why if I describing with little data set, it will happen with a big number of data set also. Okay, it means if you want to find out mean, then what mean will describe? Mean describe that the data is spread throughout entire column. It means you have 2 lakhs rows, and if you put this data, then it will be also 2 lakhs, okay, approx, if it's not missing, data is not missing there, okay. Then it will give you that what is the tendency, what is the central tendency of this. For that you have to take a mean value, okay, and then you can get, and you can say that your mean of that column is 17.8, means the data is distributed near about this central value. That is the, suppose this is the 18, okay, it's near about all data are spread. Okay, we can understand that, okay, your data is like this. But of course, in mean it suffers from some big data or low data. It's called outliers. Okay, we will discuss about this, but you have to check that what is the mean. Okay, and then you may check that what is the median of this. Okay, median, the middle point of this, and how you can find, but your Python, it's a very simple command, dot median you can write, the median will become, okay, and it will observe that what is the middle value of that entire data set, okay. And it's also that it does not suffer, okay, ascending, descending, either way you can do, how to find the median. Suppose the value is there, then you have to either put in ascending or descending, and you have to find out the middle value. If it's a odd number, then you can get the exact value. If it's not, it's an even number, then you can get two middle value, and you have to take the average of this like this, okay, and then the median value will be there, okay. Now the things are there, okay. If you see that the frequency of your data set is too high, then you can go for mode, okay. And in mode it say that how many values are repeatedly repeating in your data, in your column, okay. Okay, and suppose it's only one value. If you find that the frequency of one point is very high, then it will be one, okay, unimodal. If it's a two, then bimodal. If it's a more than one, then multimodal. Okay, these three concepts are there, but where you can use these concepts, the problem is this. Okay, problem is that suppose one case that you have to describe your data set, that what is the column values, how it's a central tendency. But another important thing related to the missing value. Okay, suppose your data is there, okay. Suppose in this case, suppose some data is missing, okay, missing, and in general, in your data that you are going to download or you are going to capture, lots of data will be missing, okay, and this is the common thing that we have to discuss, okay. But how we can fill the value, this is a question, okay. How we can fill? We must fill the appropriate value so that the model accuracy must be high, okay. Then in this case, if you analyze your data, okay, your column, that how spread it is, how it's spread from center, or what is the tendency of the center point, then according to that you can put the value, okay. You can replace this missing value, because you don't know this is 16, but anyhow unfortunately someone did not type it, and you need to put 16, okay. And here it's 21, you need to replace it, but you don't know what is the value. In this case, mean, median, mode, either you can select, but again you have to justify that why you use mode, why use median, why use mean. But generally, in general, people will use with mean, okay. But do not go for general, because now you are advancing your skill. You think yourself that what is the good option for you, okay. Suppose your data is repeating too much. Suppose 50% of data is repeating. Suppose 11 is very high place and the mode is 11 in your data, then high probability that this value may be 11 or this value may be 11 if that mode is there, okay. Suppose your average value is there and it's very close, okay. The dispersion from mean is very close, then more or less the value will be your mean value, okay. Like that, you have to think, you have to justify that your replacement is good. But in general, the people will do two ways. First, they replace with zero or they replace with mean. Okay. And now you realize that mean will be not good if mode is present in your data. Okay. If bimodal or multimodal is there, then mean is not good option, okay. And one, of course, this is not good, because if you put zero, okay, then see what is the things, the age. Suppose this is a age and you are putting the age zero, it means suppose a kind of medical things are there, then the machine learning will learn that the zero age people has such kind of disease or such kind of problem, medical problem. But the age actually it may be elder or young, okay, like that age may be there. That's why to use these kind of concepts, you have to analyze, you have to justify, and this justification you need to explain in your technical document, okay. Now the another thing, okay, consider 2 points is a multimodal. You can see here how you can find. You have to find out the frequency, and according to that, you can say that mode is there. Here, bimodal is there. Okay. Okay, and here in general, mean in the accurate measure to describe the data when we do not have any outliers present. Outliers is not there, then your mean will be more or less actual value, okay. But outliers is there. Suppose if you find the mean of this value, and if you add some 10,000 point, 10,000 number, okay, in this, then you can see your mean will be very high, and that will not describe your data set actually. Actually, we want to describe our data set as close as possible. Why? Because that this value you can use, okay, to fill missing value or for another purpose. This is the major things that we have to think um, on these things. Another thing, you can check dispersion variability from the central point. Then how much data is vary from the central point. The simplest thing is absolute mean deviation. It means from mean. Okay, the what is the deviation is there. Okay, and then the second is yours, and you know how to find. It's written, the average is there, x bar, you can see the 17.8, and then the each point, the difference of each point we are going to calculate either negative or positive, since it gives you always positive, and then after you divide by numbers, it will give you absolute deviation of mean, okay. But and you can check that this is 2.53 is the deviation. And if you want to know the variance, okay, then you have to square it, then the difference will be more. You know, if you are not able to find the difference, okay, since it's a very small, then if you square it, it will be bigger, and you can visualize that yes, this is the difference between that, okay. And like that, you can use variance. Here variance, the formula is there. And then after, if you want to find the negative and positive both direction, the variance from the mean, then you can use a standard deviation. It will give you a square root of variance, plus minus both will be there, okay. And mean is only measure of central tendency that is affected by the outliers, which is turn impacts a standard deviation. Why it's affects on a standard deviation? Because the mean is there and it's affected by outliers. Okay, like that you can find out the things, okay, to know your column, the data. And you also mention the range, what kind of range in your data set. Suppose you have 2 lakhs rows, 2 lakhs data, but it may happen that among 2 lakhs the range may be maybe 0 to 10, only this range is there, and among this 0 to 10 you have whole 2 lakhs data. Okay, that's why range is also important to find out what kind of range is there, which represents your data set. Okay, and the another thing is outliers. You have to know that what kind of outliers is there. Okay, how many outliers are there. For that, you have to find out first interquartile range. Okay, how you can find these quartiles, so that after analyzing the quartiles you can find the outliers. Okay, the quartiles you can divide into 4 parts. Okay, and how you can divide in 4 parts? You have to find q1, q2, and q3. Okay, if you find the q1, q2, q3, then you can find the quartiles of that data set. Okay, the entire data set will be divided into quartiles, and from that you can analyze that what is the description, what is the nature of your data set. Okay, because we want to handle the data set, and to handle anyone you must know the nature of that. Okay, that's why we are going to find out the nature of the data set. And here you can see in this quartile, you can see that before q1 it's 25% because it's divided into 4 parts, and q1 to q2 is the 25, and similarly 25, 25. But the range between q1 to q2, we usually say interquartile range. Okay, and you can find q3 minus q1. Okay, and here to draw the interquartile range, how you can divide, because it's general problem with a student. Then if I ask the question and they start to divide like first quartile like this, okay, one, two, like this, and then they stuck here. Okay, this is the problem. You should not start from here. Okay, just like 1 to 3, then 1 to 3, then 1 to 3. Fortunately you will get the quartile, but most of time you may track. Okay, uh, that's why you have to, okay, you have to more careful about this. It is, where is that? It is all right. Okay, okay. Now, how we can find it? The simplest thing, that you have to find the median of this. First, you have to sort it. Okay, find the median of this. Okay, and then from median, the median means quartile 2. Okay, median means quartile 2. You have to find the median, and then after from median, you have 2 parts, because median is divided into 50-50. Okay, and then after you can find another median, and then it will be your q1, and this median will be q2, and the first one, sorry, q3, and this one is the q1 that you do. Okay, in this way if you divide, then you can find the things. And the here lowest value is 3, highest is 18. Okay, and then in this way you can draw a box Whisker plot, and box Whisker plot is saying that this is your q1, this is q2, this is q3, and you can see the nature of your data set, that how much it's spread throughout the things. Okay, it means it's saying that 25% data is from 3 to 4 range. Okay, and 4 to 10.5, this is 25% data. Okay, among all. Okay, if this is talking about percentage, then you can think about 2 lakhs or 5 lakhs data set, then how many kind of data are there. Okay, and the interquartile range, you have to only differentiate q3 minus q1, you will get it. Okay, and since this is the even kind of data, that's why you got between. Okay, but if you have even odd kind of data, 1 2 3 7 8, okay, this is also even. Okay, okay, odd is there, 3 is 7, that's why you can get exact middle. And this is your q2, that is median. Okay, here is the median. Okay, you can get the link and you can find out the more information there, since I am little bit fast. Okay. Now, after that, remember, if you find the Q1, then you have to discard this in any case, this case or this case. You cannot use this point, okay? This point is only point, it's not related to your data set, okay? And here we consider this is a point and we exclude from further description of the data set, further analysis of the data set. Therefore, after that, we have to analyze only this 50% there and this part, okay? And we do not include this. This is the another mistake by students, okay? Now here you can see another, it's odd. You can get the middle point here because this is the odd, then this is the Q1 and this is the last one is Q3. In this way you can find, and after finding Q1, Q2, Q3, you can draw this box-Whisker plot. And this box-Whisker plot is common, you can see in the machine learning AI kind of thing, okay? Because outlier problem is there. Then the things about outliers, how we can find the outliers, how they find outliers to draw in your figure. It's simple. We have to know that outliers means the things that is very low or very high. Okay, that is the outlier. That is the, this is not nature of that distribution of our data set. By mistake, someone put. Suppose you are entering the age of person. Okay, you can understand with age. That's why I'm taking the example of age. Otherwise, lots of features are there like your cyber security. Okay, suppose IP address or something is there, but there if you expert enough, then you can find the outliers after looking the value. Okay, like you can understand with age. Okay, because you are expert to know about age. If someone say that the age entered age is 200, okay, or 2000, you cannot believe. Okay, that's why you must expertise in the domain so that you can understand that what kind of data must be in that nature, okay, or is this legal or not. Similarly, if anyone puts suppose in age 2000 or 200, then we have to find out, and we have to either you can remove it or you can replace with appropriate number. But this outliers is very useful for cyber security. Okay, in cyber security or any kind of attack, these outliers is very important to analyze, because if you find the outliers in your data set, it means you are going to detect the attacker, because this is the attacker who usually try to spam your email, okay, or block your service, internet service, using DOS attack, DD or attack. Okay, lots of attacks are there, and they usually do the out of pattern, and you have to find this out of pattern. It means outliers is very good for cyber security person. Okay, but how we can do it mathematically, we are going to add 1.5 into IQR value in Q3, that is the positive side. Okay, this is the positive side and this is the negative side. Okay, means below Q1. Okay, you have to subtract 1.5 into RQ. Okay, and in this new set, the IQR will replace with IQR plus 0.5 IQR. Okay, and here you can find if any value which is upper than this value, summation of this, you say that this is outlier in positive direction, and if any value is negative than this lower value, then you say that this is the outlier. It means this is not the natural value in that data distribution. Okay, either you pick that value for further investigation like in cyber security field, or suppose in medical field, if you find that the age of people is 2000 years old, then you have to replace it. Now how you can replace? You have different numbers that we have discussed, mean, median, mode, or in general you may go for field zero value, or in general the mean is there, as we discussed. But since I told you zero and mean is not always good, as okay, you can understand now why zero and mean is not good for age. Okay, okay. Now, okay. Now, then after we have to find out whether the value that is that is mentioned in the column is this distribute normally or not. Okay, suppose you have you have three or four categorical variable in a column. Okay, okay, and the category maybe one, two, three, 1, 2, 3, 4. Four categories are there in a column. Okay, and now you want to develop a machine learning model. Okay, to analyze this kind of categorical variable. Okay, and this is not a target, this is the independent variables. I am talking about that. And suppose four, the frequency of four is very less. Suppose 2 lakhs rows, it has only 10. Okay. And suppose 3 is also has very less. Suppose 2 only. Okay. And then it has all among all 2 lakhs, only 1 2 is there. Then can you imagine here that if you use this 3 4, then is it going to beneficial for your model? Because this is very few data, only 210 observation. Using 210 observation, how your machine learning model is going to train? Okay, it means the data is skewed. It means most of the value is 1 2 1 2, most of the value is 1 2, and then you have very here 3 4, the very less value is there. Okay, 3 4. 3 4. Okay, it means the skewness is there. This is not normally distributed. Normally distributed means all value is equal frequency in your data set. Okay, that's why skewness is important to find out. Now, since you are going to see all column one by one, you also find the skewness. Okay, how um, how it's distributed. Okay, it may be normal distributed, then it's okay, that is uniform distribution, or it may be go for positive or negative skewness. Positive skewness means it is skew from positive direction. If it's negative, then negative direction. Okay, it means you have to do something for that data set, otherwise it will not good for your analysis or uh, or or training your model. As we described here, 1 2 is not 2 3 is not good because it's only 2 and it's only 10. Okay, among 2 lakhs of data. Okay, now these plots you have to do. Okay, skewness, how you can find plot these things is very easy, as I told you. But after analyzing this, you have to show that why you are going to treat these among these, because this is positive skewed. Here this is normal. Okay, it means each category has the same value. Okay, and here you can find this is also negative skewed. We have to take care about this. And here, as a cybersecurity expert, you may think here that why it's less, why it's okay. These things we have to analyze, and these things I need from all of you, that for each column you have to see every tendency of your numerical value. Okay, if it's categorical, then we do as we discussed, but if it's numerical variable, then you have to find out these kinds of things. Okay, then after analyzing your data, that what kind of columns or their distribution, their nature you have. Okay, now you do something better or effectively. If you want to change your data set, or you want to make your data set efficient. And why we are doing these things? Because at the last we want to make a model which is going to predict. Okay, and if you have a good data set, then you may develop a very good model. Okay, that's why you have to do these things. Okay, keeping in mind that you need to develop a very good model. Okay, Therefore, we are doing these kind of activities. Now, after describing our data set, now the second work you have to mention in your document, that is data pre-processing. You must mention each section. Now you know how to write section in your overlay. Okay. First, descriptive analysis that we have described. You have to describe each column, and now you have only 44. Suppose I talk about cyber security, that I gave you the link. You have 44. Okay. Among 44, either you go for 44 or you may select few columns and then describe. Similarly, here you can do for data pre-processing. And what we can do in data pre-processing after know the data. Okay, you have a lots of methods. You can see lots of methods and lots of sub part is there. Okay, like you can go for data integration. This is also a kind of data pre-processing. Why? Suppose you have two, three, or more than one data set you have. Okay, then you have to integrate it. Okay, because you need in your model development one data set. Okay, one training set is there that is going to provide to your model. Okay, for that you have to integrate it. You have to transform if the data is not in good shape. You have to transform if your data is too much long, or your data is replicated, duplicated. Okay, then you have to go for reduction. If your data is not clean, like missing value or some outliers, okay, some unexpected values are there, then you have to do. Now you can realize that you have a lots of steps to do. Okay, not only to develop a model. Before that, in between model and data set, in between you have to do a lots of work, and you have to mention in your technical report that what you did in data pre-processing. It may happen that due to data set that you downloaded, it may happen that one or two steps or the different steps may not apply, or you may select some method, but you have to select some and mention that yes, this is the data pre-processing and I did. For data integration or for data cleaning, you can see a lots of things are there, like missing values, noisy data, that is outliers. Okay, we have to find out. And in this you can see different techniques are there. Again, I am telling you, coding of these things is very easy. Okay, in Python you can do how to fill the missing value, how to fill with mean value. The code will be available. I also gave you with a few examples. Okay, but at the end of this session I will give you some demo will be there if I have time. Otherwise you can find it easily. Okay, and you can do. Now noise data, you have to remove these things are there. And if you want to go for data integration, then you can go the things. But here, since we need only one data set, that's why these things may not require. Okay, do not go for this. That's why I told you it's a cycle, but you may or may not use all of them, but you must use some of them that is relevant for your data set. Okay. Now data transformation, you may go for this. Okay, lots of data transform techniques are there, but you can find new techniques also over internet. Please go, because every day new innovation is coming. If you find any new data transformation technique, you may add in your report. Okay, but at least you have to write these few basic data transformation techniques to apply. And where you can apply, again I am telling you, you have to transform your each future value, each column value. Okay, suppose this column value, and you find that okay, this column value mean max normalization is okay, then you have to justify that this column I use this mean max normalization. Okay, this column I use z score normalization. This column I did decimal scaling, but the justification must be there, and that thing I want to check. Okay, please write this thing very clearly, that what you are going to use and why. Okay, why you are going to use, why you want to transform, and you will do this thing if you realize the nature of your data set. Okay, while descriptive analysis, if you find the exact nature, you can pre-process your data according to that. Okay, and if you have a lots of methods, it's not matter that all methods is going to use. According to your requirement, according to your need on that particular column, you can select your basic methods. Okay, now data reduction, if you saw that the columns are not really important for your predictive analysis, you may reduce it. Okay, you have a lots of techniques. Okay, among them you can use the techniques are there. You can see all are correlated to data reduction. Okay, and okay, and some of them you can see some of them are repeated. Okay, like discretization is here also, discretization is here also. Okay, concepts are there. Okay, we will learn the concepts, and again I am telling you, if you want to use any kind of concept from here, the code will be available, you can use in your data set. Okay, here we are going to understand how we can use and what they are. Okay, now we are going to do here data transformation. Now the cleaning process I explain little bit. Okay, the codes are there, and why we use zero, mean, median, mode. I explain. Now you use little bit your brain also and justify the things that you are going to do. Okay. Now, first we explain the data transformation, how we can transform, but again, no need to transform entire data set. First, find out the nature of the column, and according to that, you have to do the appropriate action. And that action is different from a student to a student. Okay. That's why your work is not same as others, because other may use different methods to do these things. You may use different. Okay, and using that method, if you apply these methods and then you go for a machine learning model or something, the accuracy may be different. Okay, these things you have to compare or check. Okay, as data transformation. Okay, this is you have to change your format according to your need. Okay, and generally it refers to extract, transform, load, ETL process. Okay, this is different, but you can refer it, because in theoretical may be asked. Okay, and okay, the main thing is to make it efficient. Okay, how we can make efficient using data transformation. Okay, now, in the steps, these are the steps, but this is not a kind of fixed step. Okay, you may use any in any steps to make your data efficient. Like you go for only smoothing or aggregation, or generalization, discretization, normalization. In aggregation, you generally it refers to that the you have to remove the noise, okay, from the data set, and then highlight important future present in the data set. It helps the predicting the pattern. Okay, aggregation, you have to aggregate the things. Okay, like you see the group by method. Okay, like that you can aggregate. You may generalize the things. Suppose you have age. Okay, and now you want to analyze using categorical variable. Okay, you can generalize this value like young, old, kid. Okay, in this way, and the purpose is to analyze the things, to predict the things very smoothly, very accurately. That's why we are going to do data transformation, and this justification you must write in your file. Okay, now if you want to discretize the things, suppose you have a value, okay, and you want to put into a kind of range. Okay, you want to discretize these things, then you can also do. These are the methods. Okay, these are the methods. Using this you can improve your model accuracy. Okay, and after doing this you have to check that whether actually your model is the accuracy is improved or not. Okay, now, how many techniques? What are the techniques for this? Okay, suppose you want to discretize your data set. Okay, then you go for group wise, or you may go for frequency wise. These two different techniques are there. And here in group wise, you can find out for the width, because according to width you have to define each group. Okay, and how you can find the width? Width is simple. Your max minus mean, the value of your column, the maximum value and minimum value, divide by bin. Okay, and in this way, suppose the data set is there, okay, 10 to 100, you can find the bin value is 20. Now you can arrange it. Bin 1 is ranged from 1 to 20, and then 20 to 40, and then like that you can divide into group wise. But frequency wise, it's a little bit different, because birth wise it's a fixed. Once birth is fixed, okay, suppose 1 to 20, then 1 to 20 data, it may be 100, it may be 1000, it may be 10,000, it doesn't matter. But if it's 1 to 20, then the value will come here only. Okay, but see, I tell you, if suppose it's increase, okay, then the frequency affect, okay, because the frequency of that data is going to affect, and therefore, in frequency wise discretization, your boundary is not fixed always. Okay, it depends on the frequency, but group wise the boundary is fixed. Okay, in frequency, the data in a bin, one category you can define using number of data, because it depends on number of data you can change. This is changing, but here max and min is not changing. Am I right? This is changing. That's why the range of this, the bins of this will change. Okay, accordingly. Okay, these things you have to take care. This is the basic of this. Okay, now how we can okay, and what is the profit of this? You can see, if you divide the bin, then the first bin and the last bin is usually capture your outliers. Okay, which is not in your data distribution pattern or nature. Okay, and these two bins are important for as a security analyst, okay, to find out what kind of data is there, because they will capture. And you can see another profit, that you can, using these two bins, you can smooth, or you can make a kind of outlier free data set. Okay, because if you smooth this bin 1 and 2, okay, then it's almost it will smooth throughout all data. These few benefits are there from this discretization you can use, and this is written also here. Okay, use one as I mentioned you. Okay, and second, you can smooth it using neighborhood concepts. How you can smooth it? You have two methods. One is smooth by bin, and another is smooth bin border smoothing. Smooth by bin, as name clear, that you, if you have four bins, suppose you have three bins, okay, then how you can smooth by bin? You simply bin mean. Okay, mean. You have to find out the mean of this bin. Okay, and then replace all data point with this mean. Okay, similarly you have to find out this mean, and then you have to replace each data point with this mean. Okay, this is the, oh sorry, this is, yes, this is the equal frequency. Okay, this is the mean. Okay, and then this is mean bin. As I told you, you have to find out the mean, and then you replace each data point. Similarly you can do with each bin. And the second method to smooth it is the bin border. Okay, it means you have to fix the border. See, the border is first bin. Suppose third bin is there. Okay, third bin border is 16 and 20. Okay, there only one data. Okay. 16 and 20. Okay, border is there. In bin border smoothing, you cannot change the border. Okay, border will be fixed. You can see the border of each bin is same. Here 10 to 14 same. Can you see? 2 and 8. But the problem with this, we have to smoothing this, the middle value, the between value, okay, between the border. And how we can change, how we can smooth? We can smooth with this border value, the value which is nearest to the data point. Okay, suppose the data is here 19, then which value will be replaced, 16 or 20? Which one is the nearest? Which one is the nearest? You may find the difference, like 19 minus 16 3, and 20 minus 19 1, and difference is less than with 20. That's why we replace with 20. Okay, in this way, if you apply again coding part, it's very easy. If you write how to do the smoothing using bin border or bin mean, okay, they will give you the code and you can use, and the result will come like this. The basic logic behind the result will be this, okay, so that you can visualize your result easily. Now, here I have some example that I told you that how the border is changed. Okay, the range that we are giving, that is not change in group wise, but it's change in frequency wise. Okay, you can check that if you increase the frequency, then what is the effect with the border. Okay, okay, you can check group wise it will not change, but frequency wise it will change. I gave you the code, you can check while
अरे तो बोलना क्या चाहता है
running.
एग्जैक्टली वो
Okay.
बोलना उसको
Okay. Now here you can see if I increase the frequency, then how it's changing. Okay. Please do it and then think that how it's going to be happen. Since I told that the range of equal frequency will change. Okay, you can view with real code if you want to do. Okay, and if the range is not appropriate for the frequency wise, it will also give error. Okay, that the bin is not going to be unique. Okay, this kind of error you may find if you want to divide the data using equal frequency. Okay, equal frequency, some error may become due to this reason. Okay, in this case either you delete some frequency, or you may use another technique to do this. Okay, this implementation you can see in your Colab. Okay, you can run it easily. Now you know how to run. Now the another thing is normalization. How we can do normalization? We can use these three are basic method, but you can find more methods on internet. Okay, mean max normalization. In this we are going to transform the original data in linearly. Okay, see these things, after doing these things your performance, your model's performance must be better. This must be there, otherwise you cannot justify that why you are doing this. Okay, okay. But before applying this, you must understand that why or when we are going to use. Now, Z-score normalization is going to normalize this, but the things are there that if mean max, if you confident that your column, your entire column has mean and mix max, that is the fix, or you are confident enough that this is the accurate. Okay, there is no outliers. Okay, but if you have any doubt that I don't know whether is the outlier is there or not, then in this case you should not use this mean max normalize, because mean max is specifically for that column, that data which has mean and max known. Okay, and confidently say that yes, this is there. If you have any doubt, then don't go for min max, you can go for z square normalization. Okay, and using that you can smooth your outliers. It's also popular method. And another, if you want to normalize, then the third one is the decimal scaling. Okay, suppose in your data set, your data points, it's 10,000, 1,000, 20,000, like that kind of data is there. And to analyze this kind of data is very difficult. Okay, that's why you may go for decimal scaling, so that it will scale into decimal 0 to 1, and after that you can analyze it effectively, or your model may work effectively. Okay, now some examples, min max normalization. Okay, in this you can see a very simple formula is there according to that, and this is the v dash, means each point is going to be transformed. If you apply in a column, it may be 2 lakhs of points, then each point is going to be changed using this min max formula. Okay, and the new formula will be there. Okay, uh, okay. Now here is the example that we want to convert the min max. Okay, using this new range 0 to 1. Okay, then how you can use the formula is there. This is the point, the actual data point, and now it will be changed into 0.86. 66. Okay. Okay. And in this data point, the 16 is the max and this is the mean. Okay. And the new, in new, this is the max, this is the mean, and 0 is the mean. This is the formula that I have given in the previous slide. Okay. In this way, it's going to transform. Okay. And if you have any doubt about mean max, then go for Z square normalization. And in Z square normalization, it has this formula. This is new point, and this is the old point. Okay, this will subtract by the mean value and divide by standard deviation, and it's and then the value will come. And here in notes, I also written this matter is helpful if the true minimum and maximum attribute x are not certain, or if outliers surpass the minimum maximum normalization. Okay, if outliers are there, then you can go for this method. It will help you to smooth, to normalize your data points. Okay, and this is the formula, this is the example that I gave you. And here in the normalization, if you want to go for decimal normalization, okay, then you have to divide by 10 to the power j, and j is the bits. Okay, bits means the number of the length of the number. Here suppose 2 is there, then bits of this number is 1. Okay, and it should be maximum from all data. Suppose here only 2, in this you can find only 1. Suppose I wrote here 300. Okay, 300 series. Suppose then it has a bit 3. Okay, like that, you have to find out the bit, the maximum bits, and this j is the maximum bits of that point. Okay, and here since maximum bit is 1, that's why 10 to the power 1 is 10, and 2 by 10 is 0.2, and 3 by 10 is 0.3. Okay, and suppose I gave you 400, 300, and here the bit is 3. That's why it's divided by 10 to the power 3, that is 1000. Okay, it's divided by 1000. Okay, that is the thing that you can do. Again, this is the kind of conceptual things to do implementation. You have for each concept you have very small or very precise code in Python. Don't worry about that. Only you need to start your work. Okay, start your work, and if you want to transform the value, okay, then you also have some other methods. Okay, like you transform log transformation, and again these things happen according to your nature of your data set. Okay, whether you are going to transform log transformation or a square root transformation, reciprocal just is the divide by 1. Okay, this is a reciprocal. Okay, and then box normalization, and here in box normalization, it's one thing is there that if you have some negative values, okay, minus 5 to 5 are considered. Okay, then you can use here, but if you don't have, then you can use for EO Johnson transformation method. Okay, having the ability to make the distribution, it is very similar to box transformation, but does not require the value to be strictly positive. Okay, does not require the value to be strictly positive here. Okay, the value may or may not be positive, but here you have to find out the positive value. Okay, if you use any method, then again you have to see the all concept behind that and write down properly so that we can analyze it. Okay, these are the few methods that we have described. And then if your data set is big or you want to reduce your data set, then it's called dimensionality reduction. Okay, that according to your need, according to your requirement, you can do this. Okay, suppose I told you yesterday that we will discuss or we will analyze only ransomware. Okay, then in this case we need only ransomware rows. Okay, where ransomware attacks have been performed, we will reduce, we will delete other rows that mention about another kind of attack. Okay, because our need for ransomware, am I right? That's why we will delete the MITM attack, DDoS attack, these attacks, injection attack, we will delete that row. And that process is called dimension reduction according to your requirement, according to your need. Okay, and another important thing here, that if suppose two three two three columns are related, all are related to each other, okay, then no need to carry it out, because if the column are related, suppose x, second is x square, x cube, all are same, okay, if you know the x, you know the x square, x cube, okay, that's why they all are highly correlated, they are related to each other, okay, and if it's related to each other, then you cannot learn from that related columns, okay, and that's why machine learning model will also not train or not learn anything from the similar kind of column, okay, that's why we have to keep one column and delete the other similar kind of things. These things are commonly referred as dimensional reduction, and we have a lots of methods also to do this. And this since the high dimensional, it's very difficult to do. It will reduce your execution time and analysis process. That's why it's called curse of dimensionality. Okay, okay. Now here and benefit, of course, the benefit is a space will less computation time, visualization is easy, reference fusion is present, okay, we can delete it. Now techniques, you can use future selection techniques, okay, because you are going to select some futures and you want to reject them, okay, some of them you have to reject, okay, or you can go for future extraction technique, okay, these are the famous, okay, famous technique, you can get this PCA and LDA, this kind of code you can get easily, okay, because this is the manual kind of thing, it's very difficult, that's why you can go for these uh, these libraries, okay, like the PCA, and PCA will work again. If you want to use PCA, then your data should be unsupervised kind of thing, okay, or if you want to go LDA, then it should be supervised. And in this using this, they will find out the important features, and according to that they will suggest you, okay, otherwise you can go for one by one also with manual also, like variance threshold. Here you can check the variance of two columns, and you fix a threshold, and according to that threshold you can delete one feature, okay, or you can find the correlation between the features, and if they are highly correlated, then you have to delete one of them, because they are look like similar, okay, you cannot learn from them, okay, but these are the very is the burdening, okay, tuning the threshold, it's very, and it's very difficult to justify also that why you took this threshold, why you delete this, okay, for low level work it's okay, you can delete some features by looking, or by analyzing, or by seeing this kind of thing, but if you want for a good work, then you apply for some good built-in selection algorithm like PCA, okay, okay, you can also use genetic algorithm, this is also good to select the features, okay, step by regression you can also do, okay, here you can uh, okay, any of you may perform this kind of operation, because this is the basic one, and for learner it may be good that you have to select all features, all columns, and then go for machine learning accuracy, then what is the accuracy, and then you delete or drop one column, independent column or variable, and then check what is the accuracy, okay, like that you check that from which your accuracy is more, and according to that you can delete the column or add the column, okay, you can do, this is the burden, this is the repetitive or iterative kind of work, but you may plot a lots of or you may produce a lots of results using this, okay, okay, Now, the third agenda is how to perform and evaluate predictive analysis. Okay. Okay. Now here, the things are there that the conceptually I have described. Okay. Now, if you want to perform, okay, then you may use the algorithm either supervised or unsupervised according to your data set. Okay. And then perform the accuracy. But how we can do? Okay. This is the common things that if you do one time, then this code will be repetitively come. Okay, like you want to split your data set, as I told you, then this train and test is used. Okay, and above these library, you are familiar with this: pandas, numpy, matplotlib for visualization, and cboard. It's a new version. Okay, you can visualize very clear. Okay, train test you have to, if you want to split, then therefore this sklearn is very important for machine learning kind of things. This this library has a lots of functionality to perform. And standard scaler, this is for pre-processing. Because if you want to perform machine learning algorithms, then that's why the all values, all data points must be a kind of numerical value. Okay, if you feed the text or a string, then it will not take. That's why you have to standardize it in the standard scaler. You can apply this function, and your all values will be automatically scaled. Okay. Now, the matrices that we have discussed, how you can use accuracy score, classification, confusion matrix using this line. Okay, if you use this from a scalar matrix using this line, you can use. And models, now it's time to models. On the basis of data set, you have to select models. Okay, now you know how to select model. Suppose in this two class classification algorithm is there. Okay, then in classification kind of algorithm, you can find the logistic regression is there. Okay, random forest classifier. You can see here classifier. Okay, if it's a regression, it means this is a regression kind of classification, regression kind of supervised learning. Okay, now gradient Bayesian classifier. You can see the classifier is there. Okay, now these are the some popular algorithms, okay, that you can use. SBC is also using SBM is also popular. K-Naiver classifier, you can also use regression algorithm if you want to use, then its name is different. You can find over internet that if you want to use K-Naiver algorithm for regression, then it will give you another name, that is K-Naive regression. If you want for classifier, because I took these models because your cybersecurity data set has target variable. Okay, some categories is there. That's why I refer these algorithms. You may go for these. Okay. Um, and Gaussian nav bias also there. XGBoost is there. Okay, these are the very famous algorithms. Why I am telling to use this, because after that you can analyze that why the accuracy is different from different algorithms. Okay, and then you have to analyze. Okay, and the second important part, after importing these libraries, okay, you have to perform your machine learning algorithm. But before that, you have to make sure that the value, the missing value must be filled by some numerical value or some value. Okay, and in general, I told you people will fill with zero. Okay, you can fill with zero, or you may use another things. Okay, understand, you have to do something with missing value. Otherwise, result the machine learning will not provide. And here, if you want to reduce your dimension, okay, then you can reduce, you can delete. Okay, but here it's not a kind of dimension reduction. It's only one name is reduced. Okay, but here the main things to drop this column is target variable. Okay, because I told you about x. Okay, I was trying to write the name, but here you can see the four parts is X train, X test, Y train, Y test. Okay, this is related, means this is the independent variables, and according to that the level is there. Y train, and this is the level of this. Okay, and here capital X indicating that the things that I am telling for training data set is 80% of data set. Okay, and no, it's not 80%. Okay, this is the entire independent variables. Okay, and we deleted, we drop it the target, this prediction status. Okay, and we are keeping this prediction status here in the target variable. Okay, this is the target variable X and Y that we describe in mathematics representation. And now this X and Y, this is two part. First we divide into two part, all independent variables, and second part is dependent variables. Now we are feeding these all independent variables, and all the corresponding target value is fitting in this test and split function, and it is going to divide into 0.2, means 80-20 ratio. Okay, this indicates that 80-20 ratio is going to divide, means 80% training data set and 20% testing data set. Okay, this is the randomness, and this is the testify. You can use more options. You can go and check for text and split and what are the different options are there. Okay, and generally this meaning that it's going to going to pick the equal kind of levels. Okay, if you have three levels, then it's going to split your data set which has all three levels in equal proportional. Okay, like that you may use different options also. Now this function gives four value, and since you are going to unpack it, and if you unpack it, then since it's returning four value, you must have four variable, and here is the four variable, and this is the sequence there. This is the training. For training, this is 80%, and this is only independent variables. Corresponding dependent variable is there. Okay, and similarly this is for testing purpose, and the result, the final result, the actual result is there, Y test. And as I told you earlier, that while training you have to pass only this data. Okay, because this is 80% data. Okay, and for training you have to give independent variable and dependent variable also. Now this is 20% data, and here in 20% data you have to you have to test with question only. You cannot pass this answer. Okay, this is your actual value. Okay, this is your actual value. You must not pass in the machine learning model while testing, otherwise they will see the result and your model will be 100% accurate. Okay, okay, that's why you should not give this Y test. Y test while evaluating. First, we have to test our using Y train, test our model, and then we can um, do it. Now you can use scale transformation. You can scale it. Okay, the standard scaler is there, and now you can use different algorithm. You have a set of codes. Okay, you may find different code if you want over internet. Okay, you can we are going to use almost seven or eight models. Okay, now, if you want to evaluate, then you simply iterate, because model is there and items is there. Okay, dot items, how many models are there? It's going to iterate, and the name is there, model is there. Okay, and according to that, it's going to learn first. How it's going to learn? First, it's going to feed model that feed. It means the X train, X scale train. Okay, it's change name there, and the corresponding level. Both is giving to the model. The model is coming according to this item. Okay, one by one, eight model will come. Okay, and the first model is work with this, then second model, like that all model will train. And the second code is saying that prediction of your machine learning model. Okay, now model will give you some prediction, and that is the function, that is model dot prediction. And here see, you pass only one part of your data set, that is independent variables of test data. Okay. Similarly, if okay, this is for name support this, otherwise okay, this is only if else condition. Some model will train here. These two models will be for this, and the other models will be this. Okay, you can use this code. And then how you can find the accuracy? Accuracy score is going to be found with your predicted value. See, and the actual, see, this data you did not use yet. Okay, it's only for testing when you are going to find the accuracy. Okay, it's going to pass that time. This is your machine learning value, and this is your actual, and now you are going to pass, and the result is captured here. Okay, according to the name, result is going to capture. Okay, and if you want to print accuracy is there, and classification report if you want to print, then you have to use this function. And then at the end, what we are going to do, we are comparing the model. Okay, model comparison, then which result is good. Okay, only the value is there, each accuracy value is there. This value, these things will give you this part, this the upper part will give you this. Okay, this is for each model. Okay, this is an example of random forest. But similarly, the model name it will come and the value will come if you run this code. And this I disconnected perhaps. From where I disconnected?
Am I
Okay.
audible now, Sumesh sir?
Yes, yes, I am. When it was disconnected, sir?
Just 2 minutes before.
2 minutes. Okay, okay. Let me cover. Okay, now up to this point. Okay, now I think we are in the result phase. Okay, now here you can see that the result will come according to the model name because we are passing the model. We are passing the model name. Okay, and if name is this too, then this will work. Same function is there. The training phase here, this is also training phase, same thing there, only the difference between the model name. And here you can see that we have sent the data part that we have divided into four parts. This is the independent variable of training set and the corresponding value in this, the target variable y train. Okay, it means while training we have to pass question and answer both. But you can see here, while predicting, we are passing only question. We are not passing the answer. Answer of this is where? Answer of this is here. Here. See. This is the answer. Okay. But what we are going to do, we are going to check the answer of machine learning model. That is Y predict. Okay. We are going to test this. That's why we are not giving this Y test. We are waiting for Y predict. After coming Y predict, we are sending in the accuracy score function that now check this is my model output and this is the actual output. Now tell me the accuracy. According to the name, the accuracy will be captured and this is the list kind of things you know. Okay, and here if you print this, then the classification report will be printed like this for each model. Okay, this is the classification report that the accuracy is this. Okay, now precision, recall, F1 score, support, everything is there. Okay, this is for level 1, this is for level 2 because only two classes are there. Okay, everything is defined here. And now this line it will, and this will come for each model, okay, for each model, for 8 model, and this is due to space I did not add the all, okay. Now this is the model accuracy, all models, okay, the 7 models, and here you can pick the highly accurate model to use for further process. But the problem is this: if you see that the models has accuracy like random forest is 94% accurate and AdaBoost is 100% accurate, okay, it means we need some kind of justification. You cannot because most of you simply find out the result and then say that my model is this model accuracy, and you are start to compare with the others, okay. But here you have to do little bit more steps, okay, that you have to justify the thing, because 100% accurate means it's indicating somewhere it's a overfitting, okay. It means your the training set has a lots of value, okay, lots of noise, these things are there, and the algorithm, because each algorithm has different nature of training, okay, they are different from each other, they have different methods to train, okay, and the ADA boost may capture some noise or something to train to learn itself so that the accuracy is 100%, but this is not correct, okay. Anyone can raise the question that why it's 100%, okay, because it's very it's not possible to 100%, okay. It must be some 99.9999% like that accuracy, it may be acceptable. Now we have to justify after that, and for that we have to observation and next step we do with our result, okay. Now again I am telling you all steps I will share today, and you have to do these things and write in your overleaf, and I will check continuously, regularly, and all of you that will not send me, please do and do it, okay. Now how you can do observation? First you see that the best performing model was AdaBoost, that is 100%, and we may say that this might be overfitting due to a small data set. It may happen, okay, or you may take, or it may take some noise data or something, okay. It means the training time it's taking things, but if it's go on real world, then this model may not be accurate, okay. That's why we need to careful that what kind of accuracy is there, whether it's correct or not, okay. We have to cross check again and again. Now second is random forest, this is 94.29, it's a little bit good because the high precision and high recall is there, okay. But some moderate performance algorithms are there like logistic regression, okay. This works well but struggle with imbalanced data, it may happen. XGBoost perform well but random forest does better. SVM, KNN, good results but may need parameter tuning, okay. And poor performing models, naive Bayes, 45.71% accuracy. It may possible that some algorithm may not suitable for your data set, okay. Everything depends on your data set. What kind of data set you have is depend on, okay. Otherwise, naive Bayes is a good algorithm, but the performance of naive Bayes is not good here. It's only 45%, okay, and it's unsuitable for our data set, okay. Now we have to find out that why 100% is there, and why, because the candidate is two upper one. You may try, but it will take lots of effort, because logistic regression has 85% accuracy, and if you want to increase more using this, see this algorithm may more accurate with different data set, okay. But we are talking about this particular data set that we are using or I am using, okay. Here it's very difficult to do data transformation or cleaning. This process may not increase more. That's why we will keep the top candidate, and here top candidates are these two, AdaBoost and Random Forest. But now our responsibility to verify this, that whether it's actually the things are there or not, or whether we can improve these things or not, okay. These things we will check, and for doing this we can go for first cross validation, that whether the things while training is the training is perfectly going correct or not. Okay, we can do for cross validation. You can read more about this. Okay, now we can use the things here, and we split into 10 kind of things cross validation, 10 folds, and you can see the result of 10 folds: 1 2 3 4, okay, 5 6 7 8 9 10. 10 fold results are there. We are checking while training, we are checking what is the training accuracy is there. Okay, now here the validation accuracy we can find, and if you go for average, then you can find this much is accuracy. Okay, now see, in reality, the ADA that is showing 100% accurate, now it's only 91% accurate. It's less than your which random forest. Okay, it's not 100% actually. That's why the students, those who already communicated with me, that show that I have 100% accuracy, please go for the verification techniques and verify your result, and then show me that what is the actual result. Okay, one way you can verify with overfitting using cross validation. Okay, you can do this. The code is there. See, code are same. Always do not worry about code. This is the same. Only you need to change your data set. Okay, different data for different data set. You analyze, describe your data set, and see is there any dependency of code. If you have data set, you have to divide into X train, Y train. Okay, same thing is there. Only you need to change this, that you have to pass. Otherwise, everything is same. Okay, no dependency. That's why I told you, if you have a sample code, it will work for every data set. Okay, do not worry about that. Now, the second thing you can do for hyper tuning. Okay, that some parameter is used in ADA boost. Okay, or what kind of algorithm you are going to use. Some parameters are there, like learning rate estimator. You have to uh, provide different estimator, different learning rate. Okay, how fast your training is going on, and according to that you can find out whether it's actually or on which parameter, because it's showing 100% accuracy, means somewhere it's catching 100%. Then on which parameter is doing very good, we will check it. Okay, for that we can use this hyperparameter tuning test, and you can go for git search cross validation test, and here you can see the accuracy is the best parameter, because it's going to check one by one. Okay, which parameter is the best. The best parameter is 1. Okay, and number of estimates is 30, and in this the cross validation accuracy is 94%. Okay, it means this is reliable accuracy instead of this test accuracy, because test accuracy is 100%. Okay, now it's showing that model is being 100% accuracy on test data set, that is 100%, which is a strong indicator of potential overfitting. That's why we suggest to go for this, not for this 100%. Okay, now it's time to we check the our outperforming model, that this is 100%. And how we can check? I show you two techniques. You may find another techniques to check. Okay, go for chat gpt or etc. How to check the overfitting data, how to reduce it. Lots of techniques are there. Okay, you must see this, do this, and write on your technical report. This is the final requirement. And second, you can go for the second competitor, that is the random forest. Whether are you able to improve the result of this? Okay, okay, one thing you can go for these kind of hyperparameters, these kind of thing, and another thing you can go for that data transformation or normalization, that kind of thing. Here we are going to check random forest. Okay, and first we are going to check the test data, then what is the accuracy. In test data you can find the accuracy is 94.29. It's okay. Confusion matrix you can also find here, and now you know what is this. This is the false positive. Is a 2 times it's going to do false positive. Okay, this data set is very less. Okay, you have to do these things on your cyber security data set. Same thing, code will be same. You have to modify a little bit. And here you can see that level 0, level 1, and here the difference is there. Okay, now we want to improve these things, so that if you improve, then your value will detect here and your accuracy may improve. Okay, for that you can go for this data imbalancing, because it may happen that class 0 is imbalanced data. Okay, and if you want to balance, then one method is there, that is a well-known library, SMOT. Okay, this is synthetic minority oversampling techniques. It's going to it's going to fill the mismatch of the imbalance in data. Suppose you have a two categories, 0 1, and 0 has out of 100, suppose out of 100, 0 has 0 has 70 rows, and one has only 30. It means it's the mismatch. Okay, but if you use a smote, then 30 becomes 70. Okay, it will increase the rows. Okay, it means it's using synthesized data. And if you apply this is very simple. You can import using a smote. You can use it. Okay, try it. Code is same. Again, code will not different. Code is same. And if you use a smote and you want to check after that, okay, and here is the smote you use here. Okay, and the accuracy you can see using a smote is more or less same. I think exact same. Okay, that's why we go for next technique. You may go for class weighting. Okay, in random forest you can check here, class weight is there, and you can use this option. That's why I told you, you must go for each model the basic thing, that what kind of options they have, what kind of things they what kind of issues they have, what we can solve. These things you must write, okay, one by one. Now class weight, if you use balance, it's going to balance using class weight. If you use this, then again you are getting same result. Okay, it means since Moten class weight did not improve results, the data set may not suffer from severe class imbalance issue, and you are not able to increase the accuracy. But again, I am telling you, you can use the data transformation, data normalization after looking the column value. Okay, the missing value, because here what happened, the missing value is replaced by 0. See, now you use your brain, replace the missing value with another value, another point, and then check, is their accuracy improved? After that, check, is their accuracy improved? Not, then okay, this is the work for 7 days, because I will meet after 7 days. 6 days you will do. You use the data transformation technique also. Okay, if you are able to improve, then it's okay. Otherwise, we will learn another the recent technique, that is LLM models, pre-trained model, how we can increase the accuracy. Okay, or I don't know whether we can increase or not, but we will learn that how we can apply these techniques to make an efficient data set, so that we can get a good or the high performing model. Okay, please do these methods that I told you. Okay, I will share this PPT. Read again. Okay, try to implement, try to run all codes that I gave you. It's running code, has no error. Okay, a little bit modification in your data set, and you have to pass X10, Y10, it will work. Okay, type it, run it. Since time is not there, otherwise I will give you one sample code to run. But I hope, since you already run the Python code many times, you can since you already call the data set. Okay, am I right? You uploaded and call the data set. Now it's time to feed the data here. Okay, and then see the result and improve, justify the result, and then try to improve the result using the different data pre-processing technique. If you are not able to improve, it's okay, but apply that method, at least learn how to use the methods. Okay, and then we will discuss how to use LLM model to improve this accuracy. Okay, after 6 days we will meet, but keep updating the latex file. Those who did not share, please share. Okay. And in latex file, you write your collab link where you are coding. If you have any problem, you can message on WhatsApp group, or you may write in your latex file so that I can also see, I can help you. Try to do something in between 6 days. Okay. Okay, thank you. If you have any confusion, any doubt, please raise question.
Yes, any questions from your side? Okay, I don't think so. Then I think we can stop here. Already time is 1:40.
Okay, sir. Okay, I
So,
will.
and Sumi sir, you can share the PPT if students want in our group. Okay.
Yes,